Can I ask for a nomination from the committee for a chairperson, please? Are you all in agreement with that? Yeah. Ron, it's all yours.
You tell me what to do. Oh, morning, everybody. Last penny to open our hui. Oh, sorry.
Wrong seat.
Wrong seat.
What?
Wrong seat.
Oh. Thank you. Kia ora. Pete, would you open our hui? Good, everybody. Apologies. And that's it. Can we get a mover in a second there, please? Thank you. Move through to the minutes. I'll take it as read. Are there any matters arising? Thank you, Shannon. Thank you, Terry. We'll go through the action sheet now.
Yep.
Is that you?
Just any questions on the action sheet?
Page 9. Any updates from you, David? No? Any questions on the action sheet? Cool. Governance work plan? No more updates there?
The chair will be here in 30 minutes.
Well, shall we adjourn for 30 minutes?
The only thing, Chair, would be that I know Mr. Palmer needs to be somewhere else, if we were maybe able to receive his reports sooner, so that he can give the presentation.
Which one is that?
So the AUD, alternative use and disposal update.
Is the committee okay if we move to item 10.2? And we'll ask Murray to. I get more money for chair.
Through the chair, if I may just very briefly introduce Murray's work and what he's doing for us and why he's presenting today. So as part of the historic work on alternative use and disposal, Murray had originally produced options for the use of treated wastewater. And this year we have asked him to update some of that work with the national and international context on the use of treated wastewater, just to support the process of finding a beneficial use for that. And I've asked Murray to please present particularly his findings on international use of treated wastewater.
Thank you. Thanks for fitting me in. Pretty last moment. Yeah, so part of it was a literature search, literature review, but part of it actually involved touching base with individuals across the motu and overseas. So we're quite lucky. And we joined sort of forces with a company called Trility. Trility are, I think they're a Chinese company, but they're based in Australia and or coming here now anyway. So they were really helpful with links to to the whānau around the place. I guess there were sort of some key learnings that came out of this for us. And, you know, one is that each jurisdiction has specific needs. I mean, that's pretty much evident, and requirements, and quite unique, but there were certain key drivers that were like key themes right throughout. And one was, surprisingly for us, is that a concern for aquatic ecosystems were one of the main drivers. You know, you quite often see a cluster of drivers with each project, but often it would be triggered by this concern for lakes, rivers, or coastal environment right throughout the world. Declining groundwater resource was another key driver, and we've seen that here too, I guess. And of course, lack of access to fresh water to meet current needs or to meet developmental needs. But quite often, I think, just to reiterate, that initial driver was actually a concern for aquatic ecosystems. One thing that did stick out too, we found very little, if any, reference to market standards or market requirements globally, but what did come through clear was water quality per se. Excuse me. So I guess that, you know, as we know, the two scales, the two ends of the continuum, these large, low energy pond systems, and of course the more high energy filtration, reverse osmosis and stuff. So quite a variety of different methods. Shift on, Israel recycles 80% of all its wastewater, and that supplies 30% of its irrigation needs. And that's Tel Aviv, it's part of Tel Aviv. There's 2.5 million people that place serves. How do you say this, Wolf? Windhoek? Windhoek. Okay, cool. Oh, yeah, of course. Oh, sorry. Yeah, yes, yeah. Okay, first place in the world to use reclaimed water directly potable. There were two good cases of aquifer replenishment for drinking water, potable water. Yeah, Toril in Belgium, that's about 600,000, oh no, 60,000 people. And Perth, the city of Perth. Perth is using quite a unique system. They are taking the treated wastewater, treating it to drinking water standards, then injecting it into the well, into the aquifer, where it's estimated to take 10 to 15 years to travel to the actual source of drinking water for the city. Now you can track that water, same as we can here in the Makoti aquifer. You can track that by the level of conductivity of the water. And when it pops, when it's blended with the other natural groundwater, it's extracted and treated, again, to drinking water standards. Trinity said they are working on a project to bypass that aquifer process, but we haven't heard anything from Perth itself. And yeah, common in Italy, replenishing aquifers for agriculture. And of course, in Australia is probably one of the leading countries now for reusing treated wastewater. Melbourne is a significant plant. There are two main plants there, but the Western plant, which uses the pond system, they provide over 400 growers with a mixture. The waters are blended there for irrigation. And the eastern one is a more intensive, much smaller footprint. Noamotia. Now this is a really interesting case. I just go through this in a bit of detail. Noamotia is quite a famous ancient island off the Bay of Biscay. And it's Biscay, just off the French coast. And it has a very warm, temperate climate. Famous tourist destination. not a very big island, about 26 square k's, but it has no water. And so they had to pipe water across the causeway from the mainland. So they started treating the wastewater. They have a really quite a unique vegetable growing environment there. It's quite famous, but it's specifically famous for this potato called La Bonne. It's the most highly priced potato in the world, and at times it stretches up to €500 a kilogram. And it's, don't ask me why, but it must be some potato anyway. But it has to be picked by hand, and each individual potato has to be separately picked. Motia, they found that 95% of their potato production is now using recycled wastewater. I'm not sure if they do the La Bonne with them, but I think, well, it would be about right, but that's a big significant. And they use natural pond systems, aerobic and anaerobic ponds, to treat the water to that standard. On the island itself, yeah. It's quite low lying, it's quite an amazing little spot. I don't know how they pack it all in there, to be quite honest. Yeah. Didn't see any discussion. There is a little bit, I mean, we looked at the successful projects, you know what I mean? And so that skews it, really, but it's very hard to find much good information about unsuccessful projects. Yeah, so there's certainly there was no resistance in Europe. And that was the same thing we found working on that biosolid stuff, you know, with that sludge drying wetland. Yeah, that it's actually quite a valued resource. But yeah, I think, yeah, once again, it seemed to be quality that was the thing. And we noticed that with this, using the treated wastewater, it actually tended to extend the seasons, which was quite a significant point too. But in the cane fields in Mackay, they found a 62% increase in sugarcane yield. And that actually increased the farm income by almost double because of the higher sugar content in the cane. And Tasmania and San Diego are using it in vines and orchards. And some of the World Health stuff, if you've got subsurface irrigation, the water quality doesn't need to be as good. But for those crops that are eaten, salad crops and stuff, yeah, drinking water standard, excuse me. Of some interest was the fact that China, 80% plus of their crops, vegetable crops, are grown with sewage, some sort of sewage. That has been a traditional thing, I think, for generations, really. But yeah, kind of, yeah.
Sewage, but it's not treated, actually blended, is it?
We didn't really have a chance to look into that, but traditionally it wasn't. No, and if you notice with Chinese cuisine, it's quite missing in salads. Yeah, you know, there used to be lines of people waiting at the train stations for the toilets, the can toilet. Farmers would wait there in line and have turns at using it on their crops. Yeah. So we've got in Taupo here, you're probably familiar with Taupo, eh? It's quite famous. But they're just starting now to use vermicomposting for their biosolids. And they're finding that they can recycle these vermicomposted biosolids onto their lucerne, and that it's acceptable for, I think it's acceptable for lactating cattle. It's lactating cattle just can't use or limits on them using wastewater treated stuff, so they avoid it. But yeah, they've actually, Taupo recover almost, well, about 75% of the cost through the sale of their produce. But what is striking there is the quality of the effluent that they're utilising. It's pretty much, you know, you're coming out there with the E. coli of 350 to 480,000 CFUs per 100 mils. That's just about standing on its legs. But interestingly, of course, the philosophy behind this process, again, Lake Taupo was the driver, of course, was that the nutrients go into the bailage and then they're removed from the catchment. So that when they're sold offshore, so that you're actually physically removing those nutrients from the system, which is, yeah, it's a valuable thing. So I guess we had to look quickly at governance, and so there was quite a range: local authority owned and operated, private corporation owned and operated, Watercare, South Australia Water, part central government funding. This, the government, 40% they pay to San Luis. Yeah, but then they were, Mexico was actually using raw sewage as fertilizer prior to this particular, in this area. Oops, sorry, what have I done? Oh, okay, cool. Thank you. Yep, back there. That's the last one, I think. Thank you. Yep, and public-private partnerships. It's actually the local authority in Mangawhai, this Trinity are engaged with them there, I think. And yeah, they operate and run the plant, but the local authority owns it. But what was quite interesting, I guess we've seen it here, was and you've seen this in Motier, but also in Melbourne, is that the local authority owns a wastewater infrastructure, but the irrigators own irrigation infrastructure. And so I think here in Southern Rural Water, they actually have satellites. So they have holding reservoirs with satellite reservoirs from around there. But the schemes, what they do, what the successful schemes all have in common is that they are really seen as social enterprises. So no one there seems to aim for a profit of any real description. In fact, even in South Australia, it's written as a piece of statute that defines how the company can operate. But yeah, and most of the jurisdictions we looked at, the returns from the use of the reclaimed water was generally about 60 to 80% of the cost. And that often the water was generally provided at about that discount with people taking it. So there was, but overall, it came in cheaper generally from the successful ones. They all came in cheaper than discharging to natural water would have cost. And that's pretty much it. Sorry it's so brief.
Not at all, it's insightful. Any questions?
Murray, you mentioned that the public part of it, which would indicate a higher acceptance of central authority to fund some of these projects, more than everyone in the district felt good about it being collectively owned. Would you agree that they follow the money?
Sorry, Penny,
The reason why there's a lot of collective organisations in your example
yes.
is central government funding?
No. Well,
funding has to come from somewhere if it doesn't come from privately.
Yeah, I think the water is sold, the private companies do market the water, but it's generally at a discounted rate. But they do invest, yep. So there is investment in that infrastructure. Yeah, it probably would be based. There are some jurisdictions where they made it quite clear. A lot of the stuff we found, there was no actual format, and you know what I mean? We had to sort of pluck what we could. And there were some that received government funding. And Noamotia is interesting. The irrigators did have some funding. And that was probably a classic example. That's probably one of the most efficient systems that I could see. You know, the irrigators, they're called the trade union of irrigators or something. But yeah, I think it's reasonable for central governments to support local authorities as well. I don't, and some jurisdictions did. I don't know if that's, was that what you're meaning?
Yes, I think for an area like what we are here, yes, outside help does need to come to the table. Otherwise, we're just beating around on ourselves trying to build something with $1 when we can find $10 somewhere else. Yeah,
I know. I think that's very true. I think it'd be a good case, and I think we'll be making a case for government funding to certainly look at feasibility anyway.
Yeah, thank you, Murray. Really great reading, actually. When you read this, you just realise that we're definitely on the right track, heading towards that AUD concept for here. My question is, I mentioned before about the perception of using wastewater, recycled water for cropping and everything, and obviously, you mentioned you couldn't find any requirements or any legislation that had anything that would impede anyone exporting crops that were, were treated from wastewater. I mean, we're importing things now where we don't really know there's any origin from. So we've probably got a lot of product coming into this country that is produced by recycled water. So that's quite interesting actually, because that seems to be our biggest impediment, or seemed to be to start with, was that perception of particularly from local producers wanting to use recycled water. My other question is, out of all the different systems that you saw, what one stood out in your mind that would be very similar to our terrain and our bio-trickling filter system that we've got here that could be applicable for this region?
I guess something in the mixture of the Belgium case and maybe the climate that, we couldn't find much about Mediterranean systems like the Italian systems and that. But I think that I really like, even though it's in a miniature than Waimotia, of course, just of the concept and the way it's driven. But that's equally so for southern rural water. It's just at a much greater scale. So for populations that are very similar to ours, I think a lot of these are scalable to that. And certainly in Waimotia, being able to use pond systems to get up to a quality of effluent to be able to use is quite a major step. But I think you would build something, and if a lot of them still retain a discharge to water, so it's very few that use 100%. Although Waimotia and of course Israel are getting close to that. So that's something that we probably have to consider too. I think the opportunity, we didn't talk about, sorry, I forgot, we didn't talk about Oho, but there were quite a few areas that use water for industrial use. So Mexico, I think it's 53% irrigation and 47% for industry. So there's those opportunities too. If we're getting a tertiary treatment system coming up, it would be quite straightforward to tack something onto the end of that, I think. And even if there was that desire by irrigators to use this, you could perhaps have a central place where satellites were, and then you could treat it to the standard that you might need at each farming cluster or however they were structured. I'm just a little anecdote. First time City Boy comes to Ua, we got a small block of land, grows some potatoes on the most best elevated place on the section, wondered why I had a bit of subsoil. And but then these potatoes growing in the subsoil, you know, a line of yellow sandy subsoil. And of course we pulled these potatoes out, they really bulk, shared them around with all the neighbours. And then it finally clicked that there was the discharge from the septic tank. And there was no topsoil, it was all sand, but it was actually so rich in nutrients. And they just float, yeah. My neighbour Gwen Gordon, you might know, some of you might know Gwen anyway, she's a queer from, yeah, she goes, yeah, that's where your septic tank was. But anyway.
Any further questions? Sorry, Wolf?
Glass of water.
Yeah, yeah.
You use that as a measurement with all your examples. How standard is drinking quality across all of your examples?
Well, there's class A is pretty much a standard, and that is, if off the top of my head, it's less than 1 helminth, 1 parasite, less than 1 virus, less than 10 E. coli.
Through the chair, I think it's less than 1 E. coli.
Less than 1 E. coli, yes, yep. But some jurisdictions in Australia have included an A+, so they've added another standard. But so that's the basic. There are some core, and that's you really have to have that really well disinfected or chlorinated to achieve that. But there are all those other components like the emerging contaminants, and there are guidelines for those too, but they sit in a different place, I think. So it's highly treated water, yeah. But if you were going to use something, say if you had that system where you had a holding wetland or whatever, and you were irrigating from that, you would expect to pick up some more bacteria anyway, I would imagine. But yeah, that's the standard. This stuff goes and is pumped to, you know, to irrigators. Yep.
Thank you, Mark. Thank you, Chief. Well,
Just a note on that, through the chair. Just Murray, thanks for doing that work for us. It's really nice to see us moving on from the real scientific, technical work that's been done in the past, now looking at the practical implementation aspects of it. And I think that's the step change that we're seeing. We're really trying to now see what do we need to practically implement this and to get it across the line. So this work on what is happening elsewhere, what is being used for, and the governance models, etc., is really, really important for achieving our end goal. So thank you, Murray, for doing it for us. Just as an aside, I have lived in Windhoek and I have visited Perth quite a lot to see my brother. He lives in Perth, and I've drunk their water. I'm still around. And so I look pretty healthy, I think. A bit shaky. But yeah, so quite used to that. As we go through the papers, I just want to note that some of the work that we're talking about will be covered also later, because in the AUD update, we have included some funding applications that will probably touch on some of these aspects again.
Thanks, Paul. Murray, I just got a question for you. So in your research, did you come across any tangata whenua views?
That was what was notably absent, and I had Josie McClutchy working with me and doing some of the research, and she's been brought up in a pretty traditional sort of environment. And yeah, that was notably absent. In Australia, there is no attention at all. And I think, I mean, even having done this, and you know, we look at it, it looks positive from the outside. I think, and having used, you know, composted human waste and you handled it, if you like, if you put it there. I wouldn't like to tender as to how tangata whenua perceptions would fit, you know. So I think that's something that's got to be worked through for the mana whenua of the area. And yeah, I don't have an opinion as to that.
Thank you, through the chair. Thanks, Murray. Awesome. Just the work that we did with the chamber we spoke a lot, as you know, with Australia, and clearly they gave no consideration to First Nation people. They just got on and done their thing and growing their crops and doing it. So this is New Zealand, it's not Australia. So yeah.
Sorry, Chair, I do have an example in Western Australia, right up in the Green River, right up north.
Yes.
Yes,
Yep.
those Indigenous people work with that.
Yep.
Federal authorities and that up there.
Yeah. Green River.
I think that's what it is. It's right up in the Kimberley's up in the top there.
Oh, let's look that up. That sounds really interesting.
I mean, I thought the report was fascinating, thanks, Murray, and what I took from it in particular was that practical application aspect, and thinking it through. It's the alternative models of separating the treatment from the irrigation system, and the potential of working alongside public-private partnerships, giving us better access to government funds through that mechanism, and is separating it from the core infrastructure component, which they're more reluctant to service. But I think it also opens up conversation around if we begin to utilise the service of the treatment plant for a broader purpose. So for irrigation, it also broadens our rating base for who should be paying for that treatment cycle, not for the implementation, but as we know, you rate on the services you receive. So introducing those rates as appropriate when that irrigation comes online. And then finally, the opportunity that really exists in this that shouldn't be missed is that if we can deload the Makoti aquifer in the nearer region to the wastewater treatment plant, it allows for allocation further out of the region and makes more profitable land on a broader base. So we actually may achieve greater outcomes than just in the region in the wider sense. So yeah, I think it's amazing seeing what these other regions are doing. And thank you again, Murray.
Thank you. Cool, thank you.
I'll move. Page 29. Yeah, recommendations on 30.
So through you, Chair, this paper, apologies, is part of a wider paper for discussion around where we're tracking with what's going on at the moment. So the paper's for decision around the work that we've been doing to date in alternative use and disposal, but then also where we're updating on a range of work that's there, but then also making some recommendations for this annual plan towards council. So one of the things, the recommendations, if I can talk to those quickly, while Wolf's just sorting himself. What we're looking to do is around making a recommendation from this committee to council for inclusion of budget in the annual plan going forward. So the paper talks around making some recommendations for us for this financial year to take forward further the mortuary waste or the separation of mortuary waste, which the committee is aware that we have been working on. And then also making a recommendation to council to include further budget into the 2020-2021 annual plan. So after this committee's endorsement of making that recommendation to council to include that in the annual plan going forward. And that's more for the capital delivery of the separation of mortuary waste. We still have some work to do around the mortuary waste for this financial year that we're in now, but we need that money to be brought forward in our annual plan. So that's quite a key thing that we need to work through as a committee to make that recommendation.
The budgets.
Oh, we can talk about the whole.
Okay.
Are there any questions? Maybe it's easier. Sorry, Chair.
I'm happy to move those recommendations. Actually, this committee's well aware of our desire to progress the separation of mortuary waste, and we've been pushing to get this advanced for quite some time. Tangata Whenua have made their position clear that it's critical to them to see progressed. So I'm just happy to move those budgets and recommend that to council.
Thanks, Chairman. Got a seconder? Thank you, Kerry. All in favour? Aye. Sweet. You want to talk to it now?
Oh, I'm the happiest man in the world. Trying to get this along for a while.
Right.
Yeah,
What's
I
next?
second that.
What's next? Okay. So we're on item 9.1, terms of reference for the Kiwi Group on page 11.
Through the chair, there's the terms of reference, and then there's also looking at the proposed work plan, which is based on the feedback we've had to date from Tangata Whenua and WMC, and in collaboration with the Kiwi Group chairman.
This is the agenda item,
Yep.
so this effectively is superseded. So choose to move this and then go to the next.
Okay. So we'll move the adjourn paper. Thank you. And then move to the next paper.
Yeah.
Ooh. I'm sorry. Put that. All in favour? Aye. Thank you. My apologies, guys. So we're now on page 16 with the current recommendation that's there. Do we need to talk to this, or are we happy to take it as read and understood? Thank you, Larry.
Just when it comes to representatives nominate their representatives for the Kiwi Group meeting, I'd just like to discuss, history and experience, and obviously that would be taken into account, and also, the chairmanship. So I know that this is what the Kiwi Group does in its entirety, and it's great, but one would hope that there's a lot of experience in there from the previous, because it's been such an effective group and it's worked so closely with this. Management and relationships are always really important. So I just would like to make sure that was consistent.
Thank you, Larry. Penny, would you like to respond to that? Perhaps I will.
I was wondering where Larry was going. We shall endeavour to make sure that the people who are required and mandated to fill those positions do, and that they're appropriately resourced and able to make decisions as they have in the past, as Larry's request.
Just to follow on to that, obviously I wouldn't be saying that unless I thought the Kiwi Group were very successful, and I'd like to acknowledge the success and the way that they've performed in the past, and would really think that the input that they've had into this committee has been it's absolutely awesome. So yeah, that continuation would be really cool.
Anybody else?
I'm happy to move the recommendations, and I think it's a case of if you want a good team, you either pay nothing or you pay a lot. It's, and for this one, it's the former, but it's a yeah. I think we've got it covered in there. Yes.
Got a mover, seconder? Thank you. Larry, all in favour? Yeah, I'm getting used to this.
So Chair, just to know that on behalf of the committee, we will follow up with each of the iwi Trust to request formally who their representatives will be. So we'll put a letter from council to the iwi Trust around their nominations going forward to be part of the Kiwi group.
So is the nomination list of the appointees, or is it are they
We've left it for iwi to say who they would like to speak on that. It's not an approval by WMC, it's an approval by the iwi Trust who they each put forward.
Okay. Thank you. Is that your report, 16?
That's it. That's their work plan.
Yep.
So that
Nothing
terms
else?
of reference in the work plan, so that's that done. Alternative use and disposal done, so we're up to the update on the construction, page 111.
Page 111, guys, and who's going to talk to that?
Through the chair, thank you. So we've arrived at the part on the wastewater treatment plant upgrade. Today we have with us our engineers who have been working on the technical aspects to get it done. They're designing it, they're working on the procurement of equipment, etc. And I've asked them to be here today to provide you with a progress update on what we're doing. It might be a little bit technical, but we are in a technical phase at the moment, which is delivery, getting ready for construction. So I will ask them to talk to that. But at the same time, I'd also like to take this opportunity to introduce a project manager that is now assisting us in delivery of this work. We have got a dedicated project manager for the purpose of the wastewater treatment plant to make sure it is delivered as expected and to the right quality. And so that's Drew Williamson.
I'm Drew. I've been brought on from CBS to discuss the wastewater treatment plant over the life. A few other little bits that sort of tie into the wastewater treatment plant through waste, solids disposal, AUD, and sort of tying it all together. I'm not going to say too much today. I think it's there to the experts and we can say the plants together.
Thanks, Drew.
Okay, kia ora everyone. Okay, I'm going to just give you an overview of really what we've been focusing on over the last 5 months since Becca came on board as the design engineers for the actual implementation of the wastewater project. If you've got questions throughout, you know, obviously just ask them as we go rather than save them for the end if you want. So I'm going to give you an overview on the update, you know, an update on the progress. But also I'm going to show you the actual nature of the equipment, the major equipment that we're putting into this plant to achieve the treatment requirements. I'll show you what the plant is actually now looking like. We've got a 3D model of you know, where it's at, so you can see just how much engineering has gone into it so far. We've also been doing further clarification tests. This has come out of some of the work we've done over the last couple of years, looking at some of the settling characteristics. So I'll give you an update on that. And I'll talk about the recycled water that we've actually built into the design of the plant. Okay, so broadly speaking, the contract, I guess, the design contract for the upgrade of the plant was awarded in September. And in that time, so September through to February, we've been focusing on what's called the preliminary design. So this is the stage where you take the conceptual design and you work through the final outstanding options to close out anything that has a little bit of uncertainty around what you're doing, so that when we go into the detailed design, we know exactly what we're designing. There's no more optioneering at that point. And this is the time where you're closing out any changes. Once you go into detailed design, it costs a lot of time and money to make changes further down the design process. So we've gone through a process of working with council on their actual preferences, aligning with the operators in terms of how they will be operating this plant. And we've done further work on characterising the wastewater, so we've got a very good design basis. In line with that, there are 4 major equipment packages that we need the details about to progress the detailed design. So we've gone through a process of identifying those and then putting together specifications and going out to the market for those. And we've received tenders, which we've been evaluating, and will be shortly awarding contracts for those equipment pieces. So we're now effectively at what we call the end of the preliminary design, and we've gone through, over the last 3 weeks, a phase that's called value engineering, which is building in the changes that have come out of equipment procurement, as well as looking for areas where we can make the design more cost effective. This month, we are looking to move into what's called the detailed design phase. So we've got a frozen layout, frozen equipment procurement, and we will essentially be detailing the design to a level that it can then be put out to the market, to a main contractor, to price on and then build. So the time frame for that is effectively from this month through to December. So that includes 6 months of detailed design and then 3 months of actually tendering the works to the contractors, evaluating it and awarding. So we're looking to have that awarded by the end of this year. And then we're expecting that construction will take in the order of best case 12 months, worst case closer to 15 months. So that will come out of the tender process with the contractors, where they will tell us how long they think it will take to actually build. So up on the screen is the concept design. This is what it looked like back in 2006 when we went through the comparison with the alternative wetland scheme. Since then, a decision was made that it was actually better for council and Gisborne Holding Limited to keep the buildings that are on that site and actually purchase the site to the south, which is effectively a vacant lot. It was being used for aggregate storage and trucks and things like that. So that's been purchased, and we have now moved the design to that site. So we've located it to the south of the existing plant, and we've kept it towards the back of the plant. And part of that was just to retain space at the front for stuff in the future. So I haven't got a crystal ball, so I'm not quite sure what that stuff in the future might be, but we consider it's prudent to retain that space. So in terms of the major equipment, so there were 4 major equipment packages identified. The first is the clarification process, and I'll show you some images shortly. The second was tertiary filters. So these are put in after the clarifiers just to polish the effluent and get rid of any residual solids or floatable material that doesn't settle, to allow the UV disinfection to perform efficiently and effectively. The UV disinfection, which is effectively intensified light, which changes the DNA of the bugs, the E. coli and the enterococci, stops it from reproducing and renders it a lot safer. And then the last one are the screw presses. So when we did the concept design, we looked at a technology called centrifuges. Since then, we've actually operated a small pilot on site looking at screw press technology, which is a very energy efficient process. And we had very, very promising results on that. So we've now progressed the design based on screw presses. So we've had 12 submissions across those 4 equipment vendor packages. We are now at a point where we've pretty much got a preferred vendor for each, but we're working through the clarifications and negotiations and looking to award this month. So what does the equipment look like? Well, the first one, this is clarification, lamella clarification. So originally, when we looked at clarification, we looked at having two big concrete water retaining structures with the parallel lamella plates in the structures and a flat bottom with a scraper mechanism. After working through with council, we've changed it to going with more of a vendor package like this, which is an above ground steel tank system. And really some of the concerns were raised around confined space, the health and safety associated with the other structures. We've also done a lot of work recently on resilience, and this type of structure allows more kind of modifications post major seismic event.
Could you just explain why we've gone for a lamella, which isn't typical in
Oh, yes.
our case?
Yeah. Okay. So, so normally for clarification, when you've got good ground conditions, you've got lots of space, you'll use what are called circular clarifiers. And the original 2010 design master plan allowed for two 30 diameter circular clarifiers that would have taken up the whole of the BTNZ site, as well as the Bridgestone, the archives, all of that would have been effectively bowled to allow that construction. One of the things that we identified with the site is the ground is really quite poor underneath it, and it's really susceptible to liquefaction and lateral spread. And so what that means is if you've got a big circular tank and the ground liquefies, it will either break the bottom of the foundation of the tank, or the whole tank will tip. So to avoid that, you need to put a really significant ground improvement under it, and we'll talk about that a bit later. But the ground improvement associated with circular clarifiers on this site is just phenomenal. It was in the order, just for those tanks, of about 7 or 8 million. That's excluding ground improvements for the rest of the site. So we went with a compact design clarification process, which effectively the parallel plates within the clarifiers, they're the inclined plates, it allows you to have a more intensive settling area in a smaller footprint. But it is less commonly used in this type of application. So hence there has been some further work looking at testing how it will perform on the BTF effluent. Okay, so effectively what this is showing is there's two parallel trains, and each train can treat 50% of the peak flow. So the peak flow for the design we're allowing is 500 litres per second, which is a very infrequent flow. Most of the time, the plant's actually receiving about 180 litres per second. On the bottom, you can see that there's 3 sludge hoppers. So effectively, the solids will drop into those hoppers while the effluent flows up through the parallel lamella plates and into overflow weirs. And there's some photos from the trial, which I can show you. And then there's a series of manifold underneath the tanks, which allows the sludge to be intermittently drawn off. It also has a surface scum scraping system, so floating material is scraped into the scum draw off. These are a photo of typical disc cloth filters. So these are tertiary treatment device, and effectively what happens is the flow comes in and it flows through the disc cloth filter and then back out again. And these have 10 micron mesh size. So really fine colloidal material is removed in those filters, and this really picks lifts the colouring, the clarity of the wastewater, so the UV is a lot more effective. These are the new generation UV disinfection lamps. So effectively, it's an array of, for want of a better term, like neon tubes, which are immersed in the water. So the tubes, the light is emitted, the UV light is emitted through the wastewater, and basically it changes the DNA of the bugs. And the key feature with this is you don't want solids in the wastewater that can shield the bugs from the light. So getting the solids down is a key aspect to the UV performance. Once you put in clarification, it now means that you've got a solid stream, and that solids needs quite a bit of plant to handle it and store it. And as part of that design, you've got to think about, well, what is the operating timeframe for the plant? Are we processing those solids 5 days a week and storing for 2? Are we processing 7 days a week? What happens if there's, some type of disruption to the solids load out? So you're trucking. So you've got to cater for those type of abnormal events. So prior to going through a dewatering process, which is around taking the water out of the solids, there is a storage requirement, and effectively we're looking at 2 tanks almost identical to these, which is just under about 400 cubes of total capacity, which will hold that sludge that's taken off the clarifiers before it goes through the dewatering. With that comes a whole lot of pumps and macerators to make sure that, to transfer the sludge to the dewatering and make sure that there's no hairs and things like that that interfere with the dewatering process. So we'll come to the dewatering process in a moment. This is a photo of a very recent dewatering facility that has been installed at Tamanga in Tauranga. Our building won't look quite like that, and we don't have the silo to the right-hand side. That's a dewatered sludge loadout silo. But what we will have is the sludge tanks, quite a high building, because we've got some pretty big kit inside the building and we need to be able to lift it out. So you can kind of expect something a bit similar to this. Inside the building, we've designed around screw presses. So effectively what a screw press does is it's got a long skinny chamber and it screws the sludge. You introduce some chemicals which help it to bind, and then you slowly squeeze it and the water comes out. It's actually really, really low energy. So these operate with a 3 kilowatt motor each, which is tiny compared to centrifuges, which could easily be in that 50 kilowatt motor. So they're mechanically quite simple and quite simple to operate, which is one of the reasons why we've gone with these rather than the more mechanically intensive centrifuges. On the bottom right-hand side, you can see coming up the side of the building is an inclined conveyor. So as soon as you produce cake, you need a conveyance system. So there's a number of conveyors that will take that cake and move it to the loadout area. So this is what the building, the design looked like at the end of prelim design. And we've subsequently gone through a process of refinement, which I'll show in a moment, but hopefully this works. You can follow through the plant. So this is the pump station that will pick up the BTF effluent and pump it to the clarifiers. And we've got the splitter box, so the tall square structure that splits the flow between the 2 clarifiers, and then it flows out of that into the next square structure where it splits it to the tertiary filters. This shows 3 filters, but we're now progressing on 2. The building, we've now actually made that building a bit smaller, so it's actually going to look a little bit different, but it's still got the same plant. So we've now put the conveyors outside, and we've put the solids load out. So it loads out to trucks, and those trucks will be within an enclosed space to prevent odour emissions. So I think this is almost finished. It's quite an industrial plant with a number of walkways around to allow access for the operators for cleaning and maintenance.
And tourists.
Can I ask on that, why combine the flows after the lamellas just to split them again to go into the filters? Why not inline?
Yep. So we've looked at this at quite a lot of detail, and it comes down to redundancy. So if we don't combine it, okay.
If one goes down, you lose the whole stream.
Yep. But we also have a number of bypasses in there. So on this is now our current layout. So as you can see, it's got a bit smaller, particularly the building, and we now have a single UV channel. And there are some bypasses, and now those are put in there for a couple of reasons. The first one is to actually allow you to commission the plant. So when you commission, you start by commissioning one process at a time. You get that right, and then you move on to the next one. And it also allows you to, if you do have one of the streams out, you still continue partial, treatment. If you have one filter out, you'd have 50% of the filter working and 50% of the flow bypassing straight to the UV. So this is currently where we're at on the layout. Okay, so clarification. So we did some tests in 2017 and we identified the sludge settled like a bomb. It settled really, really well, but it also had a fine layer on the top of insects and kind of insect husks and scum that we also needed to deal with. The other bit is we identified that sludge building up on the lamellar plates was a bit of a risk in terms of whether we'd get solids carryover. So we identified that it would be worth sourcing a trial unit and just actually seeing how it performs. So we were able to source a tube settler. So it's still a lamellar clarifier, but it uses tubes instead of inclined plates. And that was brought to site, installed just before Christmas, and has been running since then on a range of flows. And what we really wanted to get out of that is understanding, how much solids carryover we might get, and what that meant for using tertiary filters and the impact on the UV. We've also got some sludge samples that I think are hopefully about to be sent off for further testing and comparison against, there's now draft organic waste to land guidelines, which are different to what were out in 2006 when we were looking at solids. So there's some different contaminants that now New Zealand's kind of looking at. So there's a bit more testing that needs to be done to figure out how our solids compare against that. So there's a few more, actually, this is just a bit of a video of the lamellar trial unit. Thanks, Drew. Is this yours or is this Zach's? Yeah, okay. So this is the BTF pump station that we're just coming to. So we're picking up flow from the outlet of the BTF pump station. Won't take much longer. There's the point. Then this is a 25 cubic hour rated unit. And you can see the weirs. So the effluent's coming up through the tubes and then overflowing into the weirs.
Gives you a good idea of how clear the water is after the lamella. It looks a lot clearer there than it actually looks in the photos.
Yeah.
Which show still not perfect.
Yeah. This bit here is really just following the desludge. So we effectively have a time cycle where every so many hours it just does a desludge, so it draws off sludge from the bottom, and that sludge is what will be going off to the holding tanks. How concentrated that sludge is will really be a function of how frequently we do that desludge and how long we let the sludge sit in the tank for. Okay.
So that brown liquid there is the dirty material coming off the lamella, and these are two differences between.
Yeah. So on the left-hand side, that's a typical clarified effluent. And then the jug next to it is typical sludge that we're drawing off the bottom. So it's still really, really running, which is why it has to go through the dewatering process. The two cones at the right-hand side, both of those are actually clarified effluent samples. And the reason I've shown that is to show that there is a difference in performance from day to day, and that really does depend on the kind of the flows that we're putting through it, the loading at the plant at the time. So we do have to cater for a wide range of quality coming off. And then the bottom, the photo down the bottom, so we thought that there would be a scum layer, but we wanted to be able to just prove it. So we rigged up a couple of IBCs to capture the effluent and see, okay, well, what was the scum coming off it? And you probably can't see it very clearly in this photo, but it's actually a large amount of insects, and dead insects or snail shells, or it's kind of like these husks. So that stuff we really wouldn't be able to put through the UV. So in terms of observation, so the floating material has been a bit higher than expected. And furthermore, we've seen a lot of leeches and worms actually just swimming in the effluent. So those need to come out before you can go through a disinfection process. Getting really, really good performance at high flow, and then it does drop off more at high flow. So there is some risk of those solids carrying over. We have confirmed that there is sludge accumulation on the plates, and the vendor package that we've been looking at has incorporated a cleaning mechanism to scour the plates on a time cycle. And we do recommend the inclusion of the tertiary filters to polish the effluent. Then lastly, the bit that I think is really neat is by putting in the tertiary filters, it's allowed us to put, see on the clouded area on the left-hand side, a couple of lift pumps. So that's taking the disinfected wastewater, and then it's pumping it to the next clouded area, which is the recycled water pump station. What this means is we can now use that water for the site wash water. And turns out that the treatment plant is the third largest water user, Gisborne, and it costs in the order of 16 to 20K per month of just water charges. And we're now able to significantly reduce that through using the recycled effluent. So the payback period on the recycled water for this plant is about 1 to 1.5 years. So that's been incorporated in the design. And I think I'll just leave it with the overall program in terms of where we're currently heading with the project. So,
Thanks, Rachel. Shannon.
Thank you. A lot of great information packed right into the end of that in terms of whole of life cost reductions with the reuse of wastewater. Has there been consideration for solar for powering the dewatering, etc.?
There has actually. So we have run some solar calcs on the roof areas, and to be honest, it was such a minor solar power generation that it would have run a couple of small pumps. So it really wasn't considered to be worth the capital cost for the actual solar farm. Yeah.
Okay, and on council policy, we have wood first policy in terms of construction use. So if there's potential to use wood as an alternative to steel, primarily for the building, obviously, not the support structures for the clarifiers, I'd imagine. But it should be made a consideration through a design process if it's feasible.
Yep. So on the existing stage 1 building, I don't know if you've been to site, but if you go into the inlet building, you'll see that there's these massive glulam wooden beams as part of the structural reinforcing. And that's actually a feature that we've been using in a lot of our wastewater treatment plants, because the wooden beams don't corrode. This can be a really aggressive environment. So the design that we currently have for the building uses those wooden structural beams in the roof. So absolutely, we're all behind that.
We have some produced locally in the WET project.
In the WET project?
Yes, so wood engineering technology making highly structural beams.
Yeah. And I don't know if the J&L beams are available on the local market, but they also do those type of things.
Any others? Larry?
The quality of the water that comes out of the UV, does that be applicable to industrial use at all? Or does it need to go through a wetland before it gets to that stage?
Yeah, I think it really needs to be linked to what the industrial use is. So I met with one of the industries recently, and they said that any recycled use for their water, they need to really get that approval from their market, and cited their overseas market as being the ones that they have to get the kind of confirmation from. I would expect if you were going to use that water, things like golf course irrigation, fantastic. Anything that's non-food production contact, probably be fantastic. But you'd really need to look at each use in terms of its specific risk. And coming back to what Murray talked about, a lot of the recycled water guidelines around the world are focused on virus removal. And it talks about a certain number of log reductions. And that can range from, recycled water for potable, you need about 8 log reductions. Then if you're coming down to a lower grade, it drops to about 5 log reductions. A plant like this, you wouldn't really be getting to that viral log reduction level. So my takeaway is it needs to be matched to the actual industrial use, but it certainly takes it a long way towards being more reusable.
Can I just add a little comment on that? So the water coming up the back of our plant, we put it into a wetlands. At the end of the wetland part, the viruses will need to clean it up for, because it's a wetland, which can't get any birds or anything like that. As the water actually gets dirtier through that wetland, and when it first comes out of the plant, apart from that virus. So when it comes in, it's so polished that the bacteria count is low enough that by the end of the time it goes to the wetland, bacteria count is gone up, but that virus count will not go.
Yeah, and a lot of the overseas recycled water plants, they tend to use ponds more than wetlands. And really the reason they use ponds is they're getting that really broad surface area and they're getting the light on the pond, and that is effectively what, and over a long period of time, that's what's killing the viruses. So,
So on saying that, what's the dimension of the ponds that are being used? I mean, are we talking lakes or?
like Western Water, Melbourne Water, Western Water plant is huge. If you go onto Google, you'll see that it is. So I can't remember the exact number of hectares.
Visible from the main.
Almost, yeah. It's massive. And it's an impressive plant, but it is a massive area.
Terry.
Thank you. I'd be interested in your comment, Wolfgang, to what we just said down the back.
So yes, wetlands do have natural sources of bacteria that could get into the wetland. And if you take water samples from natural wetlands, they generally do have elevated bacteria levels as compared to water that is not as stagnant or more flushing. It'll be a different suite of bacteria. It's not the human suite of bacteria that would be in there. And a huge determinant is whether or not you have waterfowl in there. So the wetlands that we are proposing are reed filter beds, which have no open water. And so there should be no contributors of, no waterfowl contributing to the E. coli and the bacteria in it. And increases in those bacteria levels would probably be akin to natural environments, would be my view. You wouldn't have replication of the bacteria coming out of the treatment plant. So it's going to be a totally different scenario. It would be the same as taking water from a natural wetland somewhere. You have the same E. coli. So you can't compare the two.
So I think coming back to the industrial use, if you're taking that water and you're applying it to orchards and those type of things, then probably fine. But if you're applying it within a factory, they will need practically potable level.
Yes. I guess just on that, is it potentially not factory? There's uses like our wastewater treatment plant, which is obviously acceptable for. There's also the potential of mixing concrete. Concrete's a high water user. There's the potential of the electroplaters, and they have high chemical rich water that they have to treat in certain ways. So there's options that don't have the same requirements as
Absolutely. Yeah.
Thank you, Chair. The stage 2, is it able to handle the flows before the BTF?
Do you mean if the BTF is taken offline?
Yes.
Yeah, okay. So the way we've configured it, if the BTF is taken offline, it would bypass and could go straight to the clarification process. Now, what we would expect is you'll probably get more odour, but this would be a pretty extreme operating situation. And the solids that will be coming off it will be different in nature, but yes, it could still go through the presses. how the plant operates in terms of their hours to process that sludge, I expect would need to go up quite a bit. They'll probably have to run closer to 24 hours to get rid of those solids because you're not getting that breakdown across the BTF. But yes.
What would be the benefit in that case? What would be the water outcome besides separating raw effluent and drying it?
So coming back to your question, yes, it could take the BTF effluent. Would it be compliant as the second part of that question? So we don't expect that it would be fully compliant, but you would effectively be getting partial treatment, which is better than no treatment.
So you said that the follow-up question is to Wolfgang with the consent variations. We'll have to acknowledge that, won't it? So there's a certain amount of bypass that's allowed in our consent. That bypass goes into this stage 2.
So I don't quite follow you. Maybe if you can reframe the question or.
So in the consent, there's bypass that can go straight to C. Yep.
So there is a bypass built into the consent to cater for really, really high flows called, I think they're called emergency flows. And that's a volume-based criteria. And from the volume, you come back to a flow rate. And so it allows flow rates higher than a certain amount to then bypass it into the sea. And that ordinarily happens when we have wet weather.
Yes, thank you. Okay. It's the volume part I didn't quite remember. So when the volumes are too high for the BTF, they'll be too high for the stage 2 as well.
Yes, yes. So the volume to the
Correct.
plant is limited by the inlet pump station. So that has a maximum flow that it passes forward. And the stage 2 plant is matched to the stage 1 plant in terms of its capacity. So what goes through stage 1 will go through stage 2. Plus we've allowed additional flow for it. We will be generating our own recycle stream within it. So that's allowed for, but not allowed for over and above that 450 litres per second.
But through the chair, and maybe Shannon's getting there, this, so the volume that gets to the treatment plant, we are trying to reduce through the drain miles project.
Yeah, thank you. I want to explore the concept of using this in independence of the BTF a little bit further because I don't think it's practical. The only physical treatment that's happening to the wastewater in this plant is UV. And if we're putting raw sewage into the beginning of this treatment plant, all we're doing is separating an element of raw sewage from the water and then trying to pass that water through UV. It's not going to achieve any of the same results. And we're going to end up with dewatered raw sewage as a to-land disposal. In that sense, it makes no sense to do it because you're essentially, all you're doing is putting it through a treatment plant to then go and dump the raw sewage at land anyway. So you would make the decision in the event either to put that raw sewage to sea or put it into land, but there's no benefit to trying to progress that to a stage where you can just put it through UV.
I'll ask Rach to comment in a second, but it depends on what you are trying to achieve. So if you are able to reduce the bacteria, for example, through the UV process, you will reduce health risks, things like that. And then you think about, is it important to capture the nutrients in that process? And maybe it's not important. Yeah, so it depends on what you're trying to achieve. So there could still be a benefit. Rachel, if you can jump in there.
Yeah, no, I completely agree, Wolf. It really comes down to your objectives and whether you, under that scenario, what would you prefer to have? Would you prefer to have it going to sea as a screened effluent, which is still better than what it was in 2007, not quite as good as what you have currently, or would you rather actually generate that primary solid stream? The second point that I want to talk to is it doesn't result in any additional capital. So the bypass that allows it to go to that pump station exists anyway. So we're not building additional costs, but it does mean that whichever way council prefers to go and what the consent allows them to do, they have the ability to do one or the other.
Anything further? Wolf, nothing more?
Nothing from you, Mr. Chair.
Is that us? Oh, move those reports, please. Thank you, Shannon. Larry, all in favour? Cool. And that is our agenda done and dusted. Thank you, everybody. Pen, you want to close our week? Thanks.